Hello everyone. This is Hayden. I'm a recent mechanical graduate. So this video is to explain how we calculate the tension in the rope by using the static equilibrium assumptions. So especially in physics, it is quite hard to understand how to properly use the correct assumptions and to make sure that correct concepts are used and demonstrated so that you get all the marks that you really need. And to further support. So in this example, I'll read through the examples together with you and we'll solve the problem together. Imagine a block is being fixed to the wall mount and is in static equilibrium. So I have already given you that the block is in static equilibrium. A force of 400 Newton is applied as shown. So yes, we know the configurations determine the tensions in the rope. And of course, I have to say, give you this. Your mass is 200 kilogram. All right. So first, before we start, we need to know what is given, right? So this is very important. First of all, we have to write down the block is in static equilibrium. So when I say static equilibrium, what I'm trying to say is my force in X as well as my force in Y coordinates is going to be 0. So for classical physics, we assume that the body is a point mass. So which means all the forces is concentrated in the centroid. I'll just say centroid, which means all the mass is located in that point. And then we have two coordinates, which is X and Y respectively. So this is a very traditional approach. Start with. And the second one is the assumption of gravitational force. For first year, we use 9.81 meter per second square. And 3 is we're going to solve in SI units. All right, this is given. My assumptions is as follows. First of all, I don't think I have much assumptions. So here, the block is supported by the ground, right? Which means there'll be a normal force. Normal force exists. That's what I'm trying to say to be able to solve these problems. So here there are two unknowns to find is tension. So if, for example, when we actually think about, you know, instead of 400, if I actually put 10,000 Newton, maybe the rope might stretch out and then, you know, it will exceed that tension, which is what we don't want to happen, right? Because we want it to be static equilibrium. We want it to be static, not move. All right. So we start with calculations. In such problem sets, it is very important to make sure that draw the free body diagram. So if I actually imagine I cut the rope and also I wrote down like that, 400 Newton like that, I actually draw X and Y coordinates because this makes my life a little bit easier to do with calculations. And I know this is my 30 degree. And of course, I will write with the red line is that there is a tension, straight line in the x direction, tension, and I have my own weight, which is m times g. So the reason we are calculating in the centroid is because of the point mass assumptions. I can actually include that here. Block is regarded as point mass because we cannot, this is the assumptions that many physics use. I won't go into details about why we use point mass assumptions, as it is quite hard to understand. All right, so when we think about that, we've got T in the negative x direction, mg in the negative y direction, and then what I've missed out is the Newton, right? No, the normal force. Normal force. I assume this is N is a normal force. T is tension. Alrighty. Let's think about 400 Newton because it is at a slanted angle. It's a little bit complicated. According to that Pythagoras theorem, I'll draw here. This is 400 and this is 30. So cos 30 is essentially A over H. So A is adjacent, H is hypotenuse. I'll just write AGJ. So adjacent in this is highlighted by this. Adjacent to 30. I wrote them as, let's say, X. This one is Y. So X over 400 is cos 30. Therefore, my X is 400 cos 30, right? So this is just using the Pythagoras theorem. And I'm gonna bring this one, copy this one to my another page. Right, so by that logic, instead of just writing 400, I can think of like this as follow. This is my tension. This is my normal force. And this one has nothing, but it will be something like that. This is my 400 Newton. This is my 30. And this is my mg. I'm just copying back, make it a little bit clearer. And I know that this is going to be 400 cos 30. So by similar assumptions, I can think of this way as well. I have to draw again, a bit annoying, but this is 400, this is 30. So sine 30 is opposite by hypotenuse. So opposite is y. So y over 400, which is this one, is sine 30 degree. Therefore, my y is 400 sine 30 degree. And then, therefore, I can just write like this, that 400 sine 30. All right. Okay. Using static equilibrium assumption, my sigma f of x is equal to 0, which means, and then I write down the assumptions that if you go to the right side, it's positive. If you go to the left side, that is negative. All right, let's think about what forces are present in the x direction, right? So T is negative because it's at tension and it is going to left. And then 400 cos 30 is on the right? So that is positive. So I've written my positive and negative correctly because I want to make sure that I want to have T on the one side, 400 cos 30 on the other side. So if I want it, I have to put the other sides, and that will give me negative 430 cos 30 degree to the other sides of the equations. And the negative will be cancelled out. Therefore, right, my tension is 400 cos 30 degree. Yes, that is simple. However, in the exams, maybe they will ask what is the normal force, right? And I assume that if you go up, it's positive, and if you go down, that is negative. So here, 400 sine 30 is positive. So right here, I won't put any sign because it's positive itself. And my normal force is positive. So I put as n as positive, and then I put the weight is negative, right? Because it's going downwards. Mg is negative. Go to 0. So I will keep n here. I want to put this and put 400 sine 30 to the other side. So for mg, it will be plus mg. My 400 sine 30 is going to be negative because it's positive, right? And my m is given by 200. So 200. And my gravity assumption is 9.81. And then if it's subtracted by 400 sine 30, that will be it. So that is the first one. And the second one is, I'll actually calculate cos 30. So for, let me change. Yeah, I'll get my tension is 346.41 Newton. And if I actually calculate the N, I'll get my normal is 1762 Newton. So that makes sense because the normal is always going to be positive, right? Because you have if it's a negative normal force, that means something is wrong. So I have to write down, therefore, my tension is 346 Newton. My normal force, because it's not arcs, I don't need to write, 1762 Newton. So yeah, thanks you so much for watching this video. I hope you understand how to solve those hard questions step by step.